Hello everyone, this is Mrs. Lopez. We are working on lesson 8 in module 2 today, applying the properties of operations to add and subtract rational numbers. And this is grade 7. Um, so we are still working on adding and subtracting rational numbers, but now we are trying to apply it on a different level from what we had before. So example 1, the opposite sum is the sum of the opposites. First off, sounds confusing. What is the opposite of the sum is the sum of the opposites. Let's take a look at every word up here. Let's think about any rational number, and by rational number, let's just think of an integer. Easier that way. Let's say 5. Let's take 5. And another rational number. Let's take -2. Okay? What is the sum of 5 and -2? It is 3, because we add the we subtract the absolute values and keep the sign of a higher number, which is 5, right? So that is 3. What is the opposite of the sum? The opposite of the sum, the opposite of the 3, is -3. So that is the opposite of the sum. The opposite of the sum, right? And that this sum that is made out of 5 and -2, the opposite of -3 here. And what is the opposite of this rational number? Is -5. And the opposite of this rational number is +2. Their sum is -3. All right. So the opposite of the sum is the sum of the opposite numbers, right? These are the opposites to this one. The opposite of the sum of this sum is the sum of the opposite numbers. Now, does it make sense? Let's take a look at how we apply that. So right now we have 3 rational numbers. We have -2 and 2/5, 3 and 1/4, and -3/5. Why am I saying -3/5? Is because here we see the subtraction problem. -2 and 2/5 plus 3 and 1/4 minus 3/5. But we know that we always need to change subtraction problems. I would say we never ever work with subtraction problems anymore. We always change them into addition. And to change it into addition, we would add the opposite, right? So -2 and 2/5 plus 3 and 1/4 plus -3/5. Now, let's take a look at these 3 numbers. How do we add them together? -2 and 2/5. How can I represent that and make it easier? Before I do that, let me see. I want to show you this one. How do I show -2 and 2/5 on the number line? And that is how, right here on the next page. First, we are going to show it on the number line, right? -2 and 2/5. So let's see here. -2 and 2/5. Here, we don't really see where -3 is. I'll show you. So this is, I would say this is a 1, -1. This is -2, so this should be a -3. So to find -2/5, I want to divide the space between -2 and -3 into 5 equal um, 5 equal spaces. So it's probably not going to be equal because just because it just happened to be that way. But here I have divided -2 and -3 space into 5 spaces. -2, this is -1/5. This one is -2/5, -3/5, negative 4 fifths, and negative 5 fifths is going to be right here. Right? So I go negative 2 and 2 fifths more. Right? So I'm adding negative 2 and 2 fifths more. Now, that's where it is important for you to understand. Here, I also have negative 2 and 2 fifths written with one arrow. Okay, and 2 and 2 fifths I can write as 2 plus 2 fifths, right? 2 plus 2 fifths, it's right here. 2 and 2 fifths more. 2 and 2 fifths more. So negative 2 and 2 fifths will have the same absolute value, right? Negative 2 and 2 fifths more. Negative 2 and the 2 fifths more. Why is it important for me to understand this? The sum of 2 and 2 fifths, 2 and 2 fifths is 2 and 2 fifths, right? The opposite of the sum is the sum of the opposites. The opposite of this sum is going to be negative 2 and 2 fifths. The opposite of the sum is the sum of the opposites. That means the sum of these two opposite numbers. What is the opposite to 2? Is negative 2. What is the opposite to 2 fifths? Is negative 2 fifths. Right? So the opposite of the sum, this is the opposite of this sum, right? Negative 2 plus 2 fifths, the opposite of this sum is the sum of the opposite numbers. That's why we need this. Isn't it cool? Now let's take a look back at where we were. So that's why I know that I can rewrite negative 2 and 2 fifths as negative 2 plus negative 2 fifths. Okay, so this is just an explanation of how I can do this. So negative 2 and 2 fifths I can rewrite as negative 2 plus negative 2 fifths. It is important because if you write negative 2 plus 2 fifths, 2 fifths is going to be a positive number, which means I will have to go the opposite way of the number line. But we are going the same way on the number line, so it has to be a negative number again. Okay, now we add 3 and 1/4. I can rewrite it as 3 and plus 1/4, right? And then I can write negative 3 fifths as it is. That did not change. So what I did, I separated negative 2 and 2 fifths into negative 2 plus negative 2 fifths. And I separated 3 and 1/4 into 3 plus 1/4 to make it easier for me to calculate. Now I'm going to use commutative property of addition. Commutative property of addition is when I can rearrange the numbers around, but the sum stays the same. And we know that in addition, the order doesn't matter, right? So I can rearrange these numbers, and I can rewrite integers by themselves and fractions separately. So I can do negative 2 plus 3 plus negative 2 fifths plus 1/4 plus negative 3 fifths. Okay, so now I can actually do integers by themselves and fraction by themselves. Negative 2 plus 3 will give me 1 whole plus, and now I would add fractions as I know how to add fractions. I can add positive and negative numbers separately. I can do negative 2 fifths and negative 3 fifths. Negative 2 fifths and negative 3 fifths will give me a positive and negative 1 whole, negative 5 fifths. Negative 5/5 is negative 1 whole. And then I have 1/4 remaining. Now let's take a look at this and how easy it becomes. 1 plus negative 1 is a 0 because the opposites combine to make 0, and I have 1/4 left. So I have my answer is 1/4. And I did not need to do all of these calculations with fractions and make it so difficult for myself. I can just deassemble the mixed numbers, work with integers on their own, work with fractions on their own, and find the solution that way. Okay, so how do I rewrite each mixed number as the sum of two signed numbers? Let's practice. How do I rewrite negative 9 and 5/8? Negative 9 and 5/8 is the opposite of 9 and 5/8. 9 and 5/8 is 9 plus 5/8, right? So negative 9 and 5/8 I can rewrite is the opposite of this sum, 9 plus 5/8. And that is going to be negative 9 plus negative 5/8. The opposite of the sum is the sum of the opposites. Negative 9 and negative 5/8. See that? So you put negative sign to both 9 and 5/8. Negative 2 and 1/2 we will write as negative 2 plus negative 1/2. And 8 and 11, 12 we are going to rewrite as positive 8 and plus positive 11 twelfths. Both numbers have to have the sign of the whole rational number. Okay? Alright, now we will do the opposite. We are going to represent each sum as a mixed number. So here I have negative 1 and negative 5/12. We are going to go on the same side of the number line, making it negative 1 and 5/12. 30 and 1/8 will be 30 and 1/8. And negative 17 plus negative 1/9 will make it negative 17 and 1/9. Remember, the sign stays when we add the integers, right? And when we add these rational numbers, it stays the same way. That's why that rule, the opposite of the sum is the sum of the opposite, works all the time. Okay, let's take a look at a couple word problems here. Exercise 4. Mr. Mitchell lost 10 pounds over the summer by jogging each week. By winter, he gained 5 and 1/8 pounds. Represent the situation with an expression involving signed numbers. What is the overall change in Mr. Mitchell's weight? Okay, we know that Mr. Mitchell lost 10 pounds. Losing 10 pounds is a negative number, so negative 10 pounds from what he had before. By winter, he gained 5 and 1/8 pounds. Gaining is a positive number, right? Positive plus 5 and 1/8. Now we need to represent the situation with an expression involving signed numbers. I'm going to decompose 5 and 1/8 to make it easier for myself into 5 plus 1/8, and that will be plus negative 10 as before. Okay, now I can work with negative 10 and 5. Negative 10 plus 5 is negative 5. Negative 5 plus 1/8 left. So now we have one number that is positive and one number that is negative. I cannot put them together because on the number line it's going to look different. If I have a 0 and I have negative 1, negative 2, negative 3, negative 4, and negative 5, and I have that negative 5 right here, I cannot add positive 1/8 to make it negative 5 and 1/8. I will have to go 1/8 back from where I was. That will make it in between negative 4 and negative 5. But how many? Let's divide negative 4 and negative 5 into 8 spaces. So this is a 4, and this will be the 8s. Okay, and 1/8 is going to be right here. When I went back, I went 1/8 back. Okay, so now we need to look at where exactly I am. I start numbering from right to left on the number line, right? So we have negative 1/8, negative 2/8, negative 3/8, negative 4/8, negative 5/8, negative 6/8, negative 7/8. Where is this number? This number is at negative 4 and 7/8. That's where we are. Negative 4 and 7/8. We did not reach negative 5 because we went to a different direction. We went 1/8 back. That makes it in between negative 4 and negative 5. And between negative 4 and negative 5, there are 8/8. We are on 7/8. Negative 4 and 7/8. Okay, last exercise here. Jesse is completing a math problem, and represents the expression negative 5 and 5/7 plus 8 minus 3 and 2/7 with a single rational number. Jesse's steps are listed below. Is she correct? Or is he correct? Sorry, justify your thinking. Okay, so we have negative 5 and 5/7 plus 8 plus negative 3 and 2/7. What did they do? So he changed the order of these two numbers. He wrote negative 5 and 5/7. Now he moved negative 3 and 2/7 to the second space and 8 to the third space. So he used commutative property of addition. Commutative property. So far, so good. Let's see what they did next. Next, they separated negative 5 and 5/7 into negative 5 plus negative 5/7. So far, so good. Negative 3 and 2/7 he changed into negative 3 and negative 2/7. So far, so good. And he left 8. What is he doing next? He's combining, again, using commutative property of addition. He's moving negative 2/7 and negative 3 spaces. So he again using commutative property. So again, no mistakes here. He decomposed negative 5 and 5/7, negative 3 and 2/7, and he just moved numbers around. Nothing wrong with that. Now, it looks like he's combining negative 5/7 and negative 2/7. Because both fractions have the same sign, we just add the signs, add the numbers and keep the sign. So we have negative 5/7 plus negative 2/7 make it negative 1, right? Negative 7/7 or negative 1. So far, so good. Now, next step that he is doing is combining negative 5 and negative 1 to make negative 6. That works. Negative 5 and negative 1 to make negative 6. And then he's rewriting the rest of it. Then he's combining negative 6 and negative 3 to make negative 9. That works. And he is rewriting 8. Negative 9 plus 8 makes negative 1. Jesse is correct. And we just looked at it. We looked at every single step. We proved that he is correct. And that's our thinking right here. It's already explained. So we can just write Jesse is correct. All right. So again, we can decompose positive and negative mixed numbers into the opposite of the sum. So we need to add positive or negative sign to the both parts of your mixed number. So negative 5 and 5/7 changed into negative 5 and negative 5/7. Negative 3 and 2/7 changed into negative 3 and negative 2/7. Not positive. Be careful with that. Many people make that mistake, and that's the biggest one. Okay, if you have any questions, let me know. Otherwise, I will talk to you later.